Hello, how are you all? I hope you all are doing good. And once again, welcome to the Counting Well Exam Prep Live session. We know exams are around the corner, and the two greatest factors of all successful exam results are revision and practice. Remember that practice doesn't make you perfect but helps you to perform better. Planning beforehand allows plenty of time for your revision. And so, we are here to shoo away your exam fear and help you revise your concepts before it's too late. So, stay tuned to the session and build up the confidence to face your exams. In this session, I will take you through two chapters: square and square roots, cube and cube roots from class 8. Let us see some basics from the chapter square and square roots. Let us see what is a perfect square. A perfect square is nothing but a natural number multiplied by itself. For example, here we have 25. We can write 25 as 5 into 5, that is 5 square. Here we say 25 is the square of 5. We have lot of perfect squares. Let us see what is a square root. A square root is nothing but a number which is multiplied by itself to form the perfect square. For example, 5 square is equals to 25. So we say square root of 25 is 5. Hence, here 5 is the square root of 25. Note that 25 is the square of 5, whereas 5 is the square root of 25. Let us see some properties of square numbers. There are some properties which square numbers show. A number ending with 2, 3, 7 or 8 is never a perfect square. For example, for the numbers 292, 93, 3877 or 208, we can see the number is ending with 2, 3, 7, 8 respectively. So these numbers are not perfect squares. So which are the numbers which we can call as perfect square? Yes, numbers ending with 0, 4, 5, 6, 9. Now, a number ending with odd numbers of zeros is never a perfect square. For example, we have the number 10. We can see the number of zeros here is 1. 1 is an odd number. That's why 10 is not a perfect square. Again, for the number 2000, we can see there are 3 zeros. 3 is not an odd number. That's why 2000 is not a perfect square. Similarly, for the number 4 lakh, we can see there are 5 zeros. 5 is an odd number. That's why 4 lakh is not a perfect square. Let us see what are Pythagorean triplets. For any natural number m, 2m, m square minus 1 and m square plus 1 are Pythagorean triplets. Here if we take m equals to 3, then we have 2m equal to 6, that is 2 times 3 is equal to 6. M square minus 1 is nothing but 3 square minus 1. We know 3 square is 9, that's why 9 minus 1 will get the value 8. Similarly, m square plus 1, if we calculate, we'll get 3 square plus 1, which is 9 plus 1 and 8. That is equal to 10. So we have 6, 8 and 10 as Pythagorean triplets. So these are some of the properties of square numbers. Let us see what are the patterns in square numbers. The sum of two consecutive triangular numbers is called a square number. What are triangular numbers? For example, 3. You can represent the number 3 as 3 dots in the form of a triangle. In similar way, you can write 45 or you can represent 45 in the form of triangle. Similarly, for 55, you can write or you can represent number 55 in the form of triangle. So if you take the sum of two triangular numbers, you will get a square number. So here we have 45 plus 55 equals to 100, which is equal to 10 square. That's why a square number like 10 square can be written as sum of two consecutive triangular numbers, that is 45 and 55. Now let us see sum of first n odd numbers. Observe that the first three odd numbers are 1, 3 and 5. If we take the sum of 1, 3 and 5, we will get 9, which is nothing but 3 square. So if you take the sum of first three odd numbers, you will get n square or you will get 3 square. Similarly, sum of first four odd numbers will be equal to 4 square. Sum of first 5 odd numbers is 5 square. Sum of 6 odd numbers is 6 square. Now, if a is any natural number, then we have a minus 1 into a plus 1 is equals to a square minus 1. So if you take a as any natural number, if you take a as 2, then you have 2 minus 1 into 2 plus 1 equal to 2 square minus 1. So if you have 2 minus 1 into 2 plus 1, then you will get 1 into 3. So this is nothing but 2 square minus 1, which is 4 minus 1. One more pattern in square number is if n is any natural number, then there are 2n non-square numbers between n square and n plus 1 square. So if you take 5 square and n square, there will be 2 times of 5 equal to 10 non-square numbers. So here the value of n is nothing but 5. Let us see how to find the square root of a number. To find the square root of a number, we first prime factorize the number. Prime factorization is nothing but writing the number as a product of prime factors. To find the prime factors, to find the prime factorization of any number, we use division method here. You can use the factor tree method as well. So you can see for the prime factorization method here, we have used division method. So we have 3 times 243 equal to 729. 3 times 81 is equal to 243. 3 times 27 is equal to 81. 3 times 9 equal to 27. 3 times 3 equals to 9. And we continue the process till we get 1. That's why we can see the prime factorization of 729 is 3 times 3 times 3 times 3 into 3 into 3. Now, we pair these numbers and write the square root. As 3 is repeated twice, we take it as once. 3 is repeated twice again, we take it once. 3 is repeated twice, so we take it as 1. And in this way, we have 3 times 3 times 3. So we have 9 times 3 is equals to 27. There is one more method to find the square root of a number, that is repeated subtraction. In this process, we keep subtracting consecutive odd numbers. So to find the repeated subtraction, to find the square root of a number using repeated subtraction, we'll keep subtracting the consecutive odd numbers, that is 36 minus 1, which is 35. We'll take 35 for the next step and subtract the next odd number, which is 3. We'll get 32. We'll take 32 in the third step and subtract the next odd number, which is 5. So we'll get 27. We'll take 27 and subtract the next odd number, which is 7. We'll get here 20. We'll take 20 in the next step and subtract the next odd number, which is 9. So we'll get here 11. We continue the process till we get 0. So we have square root of 36 as 6. Now let us see how to find square root of a number using long division. To find square root of a number using long division, we need to pair the numbers. Pairing the numbers means we need to pair the digits of the given number. Here we pair the number as 25 and 12. We should start pairing the numbers from the extreme right of the number. So here we take 1, 2, 2, 5 and then find a number which divides 12. So we have 3 times 3 equals to 9. Subtracting 12 minus 9, we get 3. We need to take the next pair 25 directly to down. So we have 65 into 3 as 325. We repeat the process till we get 0. So the square root of 1225 is nothing but 35. Let us see some of the basics of the chapter cube and cube roots. Let us see what is a perfect cube. A perfect cube is nothing but a natural number multiplied by itself 3 times. For example, here 125 is a number obtained by multiplying 5 3 times, which is 5 into 5 into 5. So we can write 125 as cube of 5. That's why we call 125 as the cube of 5. Let us see what is a cube root. A cube root is nothing but a natural number which is multiplied by itself 3 times to form a perfect cube. For example, 5 cube. 5 cube is 125. So we write the cube root of 125 as 5. Here 5 is called the cube root of 125. Note that 125 is the cube of 5, whereas 5 is the cube root of 125. Let us see some of the properties of cube numbers. Note that cube of an even number is always an even. So if you are taking the cube of even number, for example, here the even number is 2. We take the cube of 2, we get again one even number which is 8. Similarly, for 4, which is an even number, cube of 4 is 64. 64 is again an even number. Also, cube of an odd number is always odd. So, cube of odd number 3 is 27, which is again an odd number. Cube of 5, which is an odd number, is again odd number, which is 125. Let us see one more property. The cubes of the numbers ending with 1, 4, 5, 6, 9, and 0 also ends with the same digit. For example, if we take the cube of 4, then we have 64. Note that 64 ends with 4. So the cube of 4 ends with the same digit 4. Again, if we take the cube of 5, note that the cube of 5 ends with the same digit 5. Let us see one more property of cube numbers. The cube of a number that ends with 0, the cube of a number that ends with 2 will end with 8 and vice versa. Suppose you are taking the cube of 12. 12 is ending with the number 2, or 12 is ending with the digit 2. So the cube of this number will end with the digit 8. Also, if you take the cube of 8, its cube will end with the number 2. So the cube of a number that ends with 2 or 8 will end with their respective numbers, that is 8 and 2 respectively. Now the cube of a number that ends with 3 will end with 7 and vice versa. So we can remember these two numbers 2 and 8 and 7 and 3. So cube of 3 will end with 7 and cube of 7 will end with 3. No matter how large is the number, whichever number ends with 3, its cube will end with 7, and whichever number which ends with 7, its cube will end with 3. Let us see some patterns in cube numbers. We see that n consecutive odd numbers are needed to obtain the sum as n cube. N consecutive odd numbers means, in this case, we have 3 consecutive odd numbers, which is 7, 9, and 11. We take here 3 consecutive odd numbers 7, 9, 11, and we get the sum as 3 cube. You can try this for other cube numbers as well. Let us see one more pattern in cube numbers. Prime factors of a cube number occur 3 times. So here, if you take the cube of 6, so we have 216. Note that in the prime factorization of 216, the prime factors are 2 and 3, which occurs 3 times each. So here 2 is multiplied 3 times, 3 is multiplied 3 times. Next, let us see how to find the cube root of a number. Note that if a cube number has 1 digit or 2 digits or 3 digits, its cube root will have 1 digit. For example, if you're taking cube of a 1 digit number, for example, here we have taken cube root of 8. 8 is a 1 digit number, so its cube root will be again of 1 digit, that is 2. Now let us take cube root of a 3 digit number, which is 729. Note that its cube root has 1 digit, that is 9. Now, what if the cube number has 4 or 5 or 6 digits? For example, if we take cube number as 1331 and take its cube root, the cube root is 11, which is a 2-digit number. If we take a 5-digit number and take its cube, then we get 25, which is a 2-digit number. Note that the number whose cube root is taken is a perfect cube. Let us find cube root of a number by prime factorization. You can prime factorize a number using division method or factor 3 method. Now let us see the prime factorization of 9261. Note that 3 times 3087 is 9261. 3 times 1029 is 3087. 3 times 343 is 1029. 7 times 49 is 343. 7 times 7 is 49. So we have 7 times 1 is 7. We repeat the procedure till we get 1. So we have the prime factorization of 9261 as 3 times 3 times 3 into 7 times 7 times 7. Now let us write it as 3 cube into 7 cube, which is nothing but 3 into 7 cube. Since we are able to write 9261 as 3 into 7 cube, we can write cube root of 9261 as 3 into 7, which is equal to 21. In this way, we can find the cube root of a number. Let us see some tricks which are useful for exams from these two chapters. Let us see for the chapter square and square roots. It is always good for faster calculations to learn the squares of numbers from 1 to 20. Similarly, it is very better or it is very good for faster calculations to learn the cubes of numbers from 1 to 20. Let us see squares of numbers ending with 5. There is one trick to find square of numbers which are ending with 5. For example, if we take a number 35. 35 is quite a large number, and to find the square of this number quickly, we will use this trick. But for this trick, the number should end with 5. Let us follow the simple steps given. First, the last two digits of the square will be 25. You have to fix that the last two digits of the resulting square will be 25 because we have a number ending with 5. Next, the tens digit here is 3. So, the number that follows 3 is 4. We have to multiply 3 and 4. You will get the product 12 and this forms the first two digits of the square. We know the last two digits are 2 and 5 and the first two digits are 1, 2. That's why we have square of 35 as 1225. I'll repeat the procedure once again. Since the number 35 has 5 in the ending, we take the last two digits as 25, which is 5 into 5. We will note the digit at the tens place and multiply that number with the number following that number, which is 3 into 4. We will get 12. So the first two digits of the square number will be 12 and the last two digits will be 25. So we have 1225 as the square of the number 35. Similarly, you can use the same trick and find the square of 75. Take any number ending with 5, take its square using this trick, and you will be faster in your calculation. Let us see how to find squares of two-digit numbers. In this simple trick, we need to modify the numbers and make the units digit 0. Thereafter, it is very easier to multiply when the units digit is 0. For example, if you have to find the square of 53, you know that 53 square can be written as 53 into 53. Now we will write 53 square in such a way that the units digit becomes 0. So we'll write 53 square as 53 plus 3 into 53 minus 3 plus 3 into 3. Now let us simplify these three brackets. 53 plus 3 you will get as 56. 53 minus 3 you will get as 50. 3 into 3 is nothing but 9. Note that we have 0 in the ones place of this number. That's why we have 2800 plus 9. So the resulting square is 2809. Similarly, if you want to find the square of 84, which is again a two-digit number, 84 can be written as 84 plus 4 into 84 minus 4 plus 4 into 4. Now in the next step, we are going to simplify the brackets and we'll get the square as 84 square is equal to 7056. Now let us estimate square roots. This simple trick lets you to find the square root of a perfect number, a perfect square number, without using prime factorization or long division methods. But you should be very careful while estimating square roots. Let us determine the square root of 4096. The first step is to pair the digits of this number. If you have to pair the digits, you will see there will be even number of digits. So you can pair it as 40 and 96. Now note that the unit digit of 4096 is 6. So the possible unit digits of its square root could be 4 and 6. Correct? Now let us consider the pair 40. Once the unit digits of the square root is fixed, we can find the first two digits. So the number 40 lies between two perfect squares, which are 36 and 49. That is, 40 lies between 36 and 49. Here 36 and 49 are two perfect squares. That's why 40 lies between 6 square and 7 square. Hence, the tens digit of the square root is 6 because 6 is less than 7. Now, as the number obtained in step 2 is 4 and 6, the square root can be 64 or 66. Since the tens digit is fixed now, which is 6, but for unit digit, we have here two options, 4 and 6. So we can have the square root as 64 or 66. In order to determine the square root, we multiply the possible tens digits. That is, the product of the possible tens digits give the value 42. As possible 10 digits are 6 and 7. So we multiply 6 by 7, we get 42. Note that 42 is greater than 40 and the square root of 4096 will be smaller of 64 and 66. That's why the number is 64. I hope this trick is clear to all. Hence, we have square root of 4096 as 64. Next trick is to find the number to be added, subtracted, multiplied, or divided. So, while exams, you will come across questions where you must find the smallest number to be added, subtracted, multiplied, or divided to make the number as a perfect square number. For this, especially to find the number to be multiplied or divided, we use prime factorization to find that number. And to find a number to be added or subtracted, we use long division method. We will see this trick in details in our coming slides. Now let us see a trick for cube of a number ending with 0. So here we have started the chapter cube and cube roots for its tricks. Now let us find what is 60 cube. We know that 6 cube has easy way to calculate. So 6 cube is nothing but 216. What we are going to do is we will add 3 zeros to the right. So we have 2,16,000, which is nothing but cube of 60. Similarly, 80 cube is 5,12,000. We know that 8 cube is 512. That's why I've told you to learn the cubes of all the natural numbers from 1 to 20 so that you get the faster calculation here. Cube of 8 is 512. Adding 3 zeros to the right will get the cube of 80. Next, we will find the cube of a 2-digit number ending with 1. In this simple trick, we can find the cubes of numbers like 11, 21, 31, 41, 51, etc. Let us see the trick to find cube of 41. First, we write 1 and 4 in the tens and ones place. You have to start with tens place and then you have to enter the ones place. Next, we have to write the cube and square of 4 in thousands and hundreds place respectively. So what is cube of 4? It is 64, which is entered in thousands place. And what is square of 4? We have 16, so it is entered in hundreds place. Now what we are going to do next is doubling the digits at the hundreds and tens place. So if you double or if you multiply 2 to 16, you will get 32. If you double the number 4, you will get 8. Next, we will add the numbers in respective places. So 1 will be carried as it is. Sum of 4 and 8, you will get 12. 16 plus 32, you will get 59. And that's why we get in the last column 68. We are going to forward the numbers in respective columns, or we are going to borrow the numbers. We are going to take forward. So we have cube of 41 as 6, 8, 9, 2, 1. Now let us see a trick to find the cube of a 2-digit number with same digits. 2-digit number having same digits means you can find the cubes of numbers like 11, 12, 33, 44, 55 and so on. For example, if you want to find 22 cube, write the cube of 2 in thousands, hundreds, tens and ones place. So we know that cube of 2 is 8. So we have entered 8 in all the columns. Next, we are going to double the numbers for hundreds and tens place. And next, we are going to add the numbers in respective places. So in this way, we have found cube of 22 as 10,648. Let us see what are some common mistakes that students do. While finding the square root of a number, we should pair the numbers from right to the left. For finding the square root of a number by long division method, the first step is to pair the numbers. For example, if you want to find the square root of 10,609, we should make the groups of two digits starting from the units place as shown here. So in the first way, you can see you have started pairing the digits from the extreme right. So we pair as 0, 9, 0, 6 and 1. So this is the correct way of pairing the numbers whenever you are finding the square root by long division method. Now bringing down a pair while using the long division method to find the square root. So before proceeding to the next step, we should bring down the next pair. Care should be taken that the whole pair, not the single digit, is bring down. For example, bring down the pair 0, 9 and not the single digit 0. So in the first image, you can see we have brought down 0, 9, while in the second image only 0 has got down. So this is not the correct way because we are using the long division method of square root. This is not the regular division we are doing. So this is the correct way shown in the first image and this is the wrong way. Next, prime factorization or long division. Which one you are going to use when you have to find a number to be multiplied or divided to get a perfect square? So you might have seen questions like finding small number by which a number should be multiplied to get a perfect square, or you have questions like finding smallest number which should be divided to get a perfect square, or you find questions where you have to find least number that must be added to obtain a perfect square or number to be subtracted to make it a perfect square. So if you have any confusion on which method to be used to solve these problems, then note that for a number for the smallest number to be multiplied or divided, always use the prime factorization method. Here you are writing the number as a product of prime factors. That's why here you can find a number which should be multiplied or divided. And for the smallest number to be added or subtracted to make a number perfect square, we should always use long division method. The method in which you are bringing down the numbers by pairing them from right to left. So always remember for prime factorization, you can find the number to be multiplied or divided, and using the long division method, you can find the smallest number which can be added or subtracted to get a perfect square. Now let us see forming groups of 3 starting from the rightmost digit. So while you are using the prime factorization method to find the cube root of a number by estimation. Okay, we are talking about the method of estimation here. So the first step is to form groups of 3. So whenever you are forming the groups of 3 digits for any number, you should start from the rightmost digit or the extreme right of the number. For example, if you want to find the cube root of 13,824, make groups of 3 digits starting from the units place and starting from right. So you have to group the 3 like 824 and 13, not 138 and 24. So this is the correct way and this is the wrong way. So if you want to find cube root of 2744, we are grouping the 3 digits starting from the right, that is from the units place. So the number 2744 is grouped as 2 and 744. Now let us see some of the exam tips. While you're going for the exam, you have to practice a variety of questions from NCERT textbooks, exemplar, other textbooks, and from the previous year's question papers. Practicing all the questions or practicing more and more questions will help you to score better. Also, note down all the definitions and properties separately so that before going to attend the test, you have the ideas on the definitions, and also you can apply the properties to solve problems. Practice more questions on finding the square root by long division method and also finding the cube root by long division method. Avoid calculation mistakes always. Upon finding square root or cube root, you should recheck whether uh, by taking the square or cube of that number, you're getting the same number or not, or you're getting the right answer or not. Also, you should be thorough with the divisibility rule. This will help to find the square root or cube root by prime factorization method. Also, as I have told you, to learn and understand the cubes of first natural numbers from 1 to 20. So, always remember the square roots or cube. Also, remember the squares and cubes of the first 20 natural numbers. This will help you to solve problems quickly and do the calculations faster. Also, while solving word problems, always write what is given in the question and what we must find, etc. This helps in identifying the right strategy or right rules to be used for solving that given question. Always read the given question carefully and understand it. So, in this chapter, just understand whether you are asked to find the cube or cube root, whether you have asked to find to square or the square root of a number. And please do not get confused between finding the square root or finding the cube root. Just go thoroughly through the long division method. And the last point, which is very important here, is you should check whether you have all answered all the questions and parts of the questions. Many times there are parts of the questions like sub questions of a question, and you should make sure that you have answered all the parts of the questions. Are you done with solving all the sums from the textbook? Done with glancing through the classwork and solving worksheets? Do you want to revise the concepts, practice some extra sums, and also take a quick test? Over 75,000 students trust counting well for their maths learning. Even without the exam prep kit, they can learn every day on the app by diving deep into every chapter. So, exam prep kit is nothing but a tool which lets you to quickly revise the concepts, practice some extra sums, and also take a quick test. It lets you quickly glance through the major concepts of your chapter. You will also understand some of the tricks and tips, common errors that you make, etc. I hope this session was helpful, and if you want to revise more and practice more questions, you can download the app from the App Store or Play Store. Also, stay connected to our channel Counting Well and learn more tricks and tips and ways to avoid common mistakes. Well, we will be revising the chapters Rational Numbers and Playing with Numbers from class 8 in our next session. tomorrow, that is Tuesday at 6:30 p.m. Well, see you in the next session. Until then, keep learning, keep growing. Thank you.